All righty. Okay, so we're going to talk about ions. So flip to that page there, okay? And there's just kind of a fancy word, ions. Um, what is this element? So look at that picture on the right side. Count how many positives they are, because that's the number of protons. So figure out what element it is. Count how many positives there are. Anybody see? There's six. So if it's got six protons, what element is it? It's carbon, correct. So we said this is carbon. Now, how many neutrons are there? Okay, there's seven, which is fine. It can have how many ever neutrons it wants, right? Count how many electrons there are. Okay, so what's weird about this? What's wrong with it? So yesterday we said the electrons and the protons are the same, correct? But they're not. They're not here. The positives are not equal to the negatives. And that's how we call an ion. Okay, so when the charge, if an atom's an ion, it means that they have charge. Okay, so the positively charged protons are not equal to the negatively charged electrons. Okay, so in this case, it's a cancellation game. Ready? It's a cancellation game. How many electrons do I have? Seven. Seven minuses. How many positives do I have? Six. What is left over? Negative one. So this would be a negative one charged atom. Okay. And now the only thing, so steps to determine how many positives, how many negatives, and then what's left over is your charge. Okay. So how many positives, how many negatives, what's left over, and that's your charge. Okay. So uranium has 92 protons. So it's got 92 positives. And it's got what? 90 negatives. What's my charge going to be? Plus or minus 2. You're going to be what? Plus 2. You got two positives left over. Does everybody see that? Does everybody see that? You're going to have two positives left over. Because if you canceled out 90 of them, there's only going to be two positives left over. If I have 9 positives here and 10 negatives, what's left over? Negative 1. Okay, you got the idea? So now these atoms are what we call ions in their charge. Flip the page. So if there are more protons than electrons, if there's more protons, it will be positive. If there are more electrons than protons, it'll be negative. Okay? So how do I figure out how many protons copper has here? What can I do? Yes, sir. And how many has it got? 29. Okay? So what's the difference between the positives and the negatives here? Yeah, positive, positive, positive. See if you can do B and C quick. 16, and then let's see. All right, check your answers. Sulfur's got 16 positives and 18 electrons, so it's minus 2, right? Everybody good? Now, here's one thing that I want to just talk about before. Let's just write this at the bottom of the page, okay? So if I had chlorine, right? If I said how many protons are in a neutral element to chlorine, what would you say? 17, right? If it was neutral. How many are there if there's neutral? If how many electrons are there? There's 17, right? All I did was just find the atomic number, and then I said this. Now, here's what you got to start thinking about. Chlorine minus or chlorine positive, okay? So if it's chlorine minus or chlorine positive, here's what you have to, here's one thing that I always want you. Chlorine, to be chlorine, you always have to have 17 protons. All of these are going to have 17 protons. You can't change you cannot change that. You can change the charge like negative, positive, negative 2. But you cannot change the number of protons. If it wants to be chlorine, it has to have 17. Okay? So the electrons, okay, component here, if it's negative 1, negative 1 here, how many electrons do I have to have? Okay, we can manipulate the electrons. How many electrons do I have to have to be negative 1? Say louder. 18, right? 18. Because that's, I need 18 to be negative 1. Okay? What about positive chlorine? How many electrons would I need to be positive? 16. Notice these changed, right? And that's okay. That's okay. That's totally fine, right? It's totally fine to have the proton or the electrons change. Totally fine. All right. Yay? So charge deals with what? Manipulating the electrons. Sound good? Let's do a couple on the chart. I'll turn you loose, and then we'll pretty much be done hearing from me today. All right. So in this case here, now I always like to do this when we chart. I always still do this. Mass is equal to protons plus neutrons. Okay? Mass is equal to protons plus neutrons. All right? So if the mass is equal to protons plus neutrons, okay, let's figure out here. Let's just isolate this. 35 is equal to 17 plus 18. You got it. That's mass. That's okay, right? Now let's talk about charge. Okay, so now I want to talk about charge. And when I talk about charge, I talk about protons and electrons. Okay? 17, right? And 18. What does that leave me with? Negative 1. Okay? And that is also indicated by that right there, too. Okay? This chlorine, this minus part right here. Let's do another one. Mass. Oh, no. Mass first, right? 19 is equal to 9 plus what is going to give me a 19? 10. Yep. Okay. 10 electrons. 9 positives. Same thing. Yeah, same thing, right? Minus 1. See if you can do the next 3. See if you can do the next 3. See if you can do the next 3. All right. See if you can do the next 3. Check the potassium one. Okay. It's positive, right? It's pod 39, so 30 and the masses together, that's separate. Now let's look at the electrons. Protons, how do I know it's positive? Because of that little symbol right there, right? That positive. So then I have to say, okay, what do I have to do to the electrons to make it positive? And it's take away an electron, right? You can take them away. You can break it off. Okay? Iron. 26 plus 32 is equal to 58, right? 58 iron Fe. Okay, if the protons and electrons are equal, does anything change? Does it matter? If these are equal to this, guess what the charge is? 0. Right? Doesn't change. Beryllium, Be. Okay? Be. 9 is equal to this plus this, right? And then how many electrons? Well, I got 4 and 2. 4 positives, 2 negatives. So it's going to be plus 2. You guys got it? Thumbs up. Feel like you got ions. Thumbs up. Feel like you got ions a little bit. Okay. Now here's what. Let's see. I think that's it. Sure is. Here's what we're going to have to do. Get that green. Backside here. Actually, you know what? Okay, let me ask you this. Would you do this at the end of class, or would you rather do the online thing right now? Take a break, do the online thing, and do this at the end. Online thing? Yeah, I think so too. Because there's actually a couple things on here that'll be good for you to do the online thing. You can keep following me, it might help you. Okay, take a break for a minute while I get the other stuff situated, okay? Keep your notes and stuff out as well.